Hello, we are here for one more lesson of this T-Flex CAM training course, and the topic for today will be also the 3D milling. In this particular case, the video number 4 of this 3D milling. And in specific, the 3D milling today will be something called the pencil machining. I will use the same part as we've been using for some of the previous examples. This is a cavity, and my preparation for this video was to create on the edge in here I've created a 3D path. Apart from this detail, the body is completely standard. So again, we need to go to CNC menu. Then this is another type of toolpath. So it's inside the boundary 3D milling group. When we click here, the auto menu opens these options. You already know these options. And we've seen this rough milling, the fine milling, and today this icon here called the pencil milling. The idea of the pencil milling, before I show you how to create the toolpaths, is to mill in edges, in corners where you need to pass a tool to reduce material or to uniformize the material that you have in these specific areas. So when we open the function, we can select several things, and the first one we can select is the full body. So I can pick my solid, simply this, and now I can choose from a face or an edge. For example, if I select a face, I can select this face here, and the limits of this face will be selected automatically for the machining. So without anything else, if I choose my file, you know already this file also, I'll choose the tool number 3, that, as you can see, it's a 20 mil diameter round tool, and I will simply say go. And what happened, it created a toolpath from the limits of this surface that we choose. Let us do a quick simulation of this. As you can see, I'm not making comments on the parameters. I'm just showing you that with that particular choice, we've created a program on the limits of the surface we choose. Another possibility, it is to, and I will delete now the program, it is to, instead of selecting the body, I can choose an edge. For example, I can choose this edge here, and if I choose an edge, there is no need to choose the body. So with this edge selected, I will select again my tool file, the same tool, and again, without being worried about the parameters, simply do the accept, and as you can see, it created a toolpath which has this result, something like this. Okay, very nice. Still another possibility for this type of toolpath, it is to choose a 3D path. And in this particular case, as I mentioned when we started the video, I've created a 3D path on the edge of the cavity. So pencil milling, now instead of edge I will select a routing path, and I will select this entity here, now selected in blue, Again, my tool file, my tool, again, the same tool, and simply do this. Let's try to simulate. I would expect something created, and here it is. Very simple. So 3 choices to create the same toolpath. So now, in terms of parameters for this pencil machining, feed rates, rapid feed rate, working feed rate, it's already known. The L1s, cooler on or off, spindle rotations and directions, all of this is already known. So pass type, zigzag or loop, this is also okay. Tool lift, again incremental, and I have this parameter. This is in here where we inform the system about the possibility to make this toolpath in different layers. So I can say this is the entry material and this is the exit material. And the idea is, if I say starting, I have 5 millimeters of material, and in the end I will have 0 material. So in each layer I will have 1 millimeter, and if I say calculate, as you can see, let us simulate it, it's a kind of stock material that we inform the system, and it will do this in layers. The option of the zigzag, as you can see, will do one pass in one direction and the other one in another direction. So if I choose the loop, basically we'll make everything, and we can try to do it. So instead of zigzag, just do the loop. It's basically the same appearance, but in terms of the simulation, okay, as you can see, makes all the layers in the same direction. More parameters about this. So material, start, material in the end, Z layer, deepening. We have this side offset. This side offset is interesting because we can choose, for example, an edge. We can have also this parameter chosen, and if I say calculate, what it does is it will make an offset on the vertical wall, so it's also interesting. So besides this side offset, so you can have a number, a value here. We can indicate that it's a vertical wall, because if you don't say that is a vertical wall, this example here will have a different behavior. Let's try to simulate the situation, and it will do something like this, which is a little more strange. So I would say that regarding this parameter, it's always important to say vertical wall instead of non-vertical wall. These are the directions also, and we can do a very interesting parameter, which is the reflect the toolpath. Let's simulate this to see what happened. And this reflection will create what you can call a symmetry regarding what is chosen. So in this case, the toolpath was outside of this entity. Now it is inside, and the same for the vertical wall. So it will create a toolpath on the opposite direction. Then we have also, I will take this out, we can connect the plunge machining that will create increments in each pass. I will not consider this as an important parameter for this kind of toolpath. Again, we can create high-speed machining trajectories with this. To be very honest, I will not say that this is very important also, and I will calculate a toolpath so that you can see what it does. So it will create a lot of movements, but I would say not very interesting in this particular case. And after this, so I speed, I will take this out. Approximation, I have the circular interpolation, and I can make this a little bigger so the program will be a little lighter. And again, also the tool rotation considering the tool vector that you define. So something like this. And okay, these are the options to create these pencil machinings. There are a lot of interesting characteristics that you can add. The program needs this auxiliary information by the user to insert either the edges or the surfaces we want to do in terms of milling. But it is very accurate in this toolpath type. It's very fast, so I think it's a very good additional option to what we've spoken until now in terms of finish milling and rough milling also. Any questions, any details that you want to be more clarified or better explained besides what is spoken in this video, we are here for supporting your questions.